So in last discussion we were discussing the set problem, and we have discussed the example of set problem, that is the set formula, which is having three liquids in each clauses and they are connected through the AND operation. So there are three facts about K-set problem. Every Boolean formula has an equivalent CNF formula, but the size of the CNF formula may be exponential in size of the original. Not every Boolean formula has a K-set equivalent. And third factor is 2 set is NP and 3 set is in NP complete. So 2 set is in P, we can assign for some variable say x equal to 2. Any clause with minus x forces the other literal to be true. For example, is an expression which is representing 2 set. So the only 2 literals are there. So x is assumed true. So this part will be false. So we can force this part to be true to make this total clause as true. So for making this part to be true, it is necessary y must be false. So if we can force the other variable accordingly, then we can say that this is a satisfiable problem, and in polynomial time we can assign the proper value to the variable. So one of the three things can happen. You reach a contradiction when you are forcing the value to be true or false. You reach a point where no more variables have their truth values forced, but some clauses are not yet made true, and you reach a satisfying truth assignment which we are expecting. So case 1, there can only be a satisfying assignment if you use the other truth value for x. So simplify the formula by replacing x by this truth value and repeat the process. In third case, you found a satisfying assignment, so answer will be yes. But in case 2, you force values for some variables but other variables and clauses are not affected. So adopt these truth values, eliminate the clauses that they satisfy and repeat. So if you do like this, you will reach to a satisfiability. So in case 1 and 2, you have spent big O of n square time and have reduced the length of the formula by greater than equals to 1. So big O of n cube total. 3 said this problem is NP complete. Clearly it is in NP since set is. It is not true that every Boolean formula can be converted to an equivalent 3 CNF formula, even if we exponentiate the size of the formula. But we don't need equivalence, we need to reduce every CNF formula f to some 3 CNF formula that is satisfiable if and only if f is satisfiable. So reduction involves introducing new variables into long clauses so we can split them apart. So to reduce C set to 3 set, we are considering let x1 to xn be a clause in some C set instance with n greater than equals to 4. So the x are the literals, not variables, so any of them will be negated variables. So introduce new variables y1 to yn minus 3 that appear in no other clause. So the placement of these new variables will be like this for a given expression. So suppose the expression is x1 to xn. So you are introducing this y1 i2 up to yn minus 3 with this special kind of property, like here when you are keeping y1 true, in the next clause it is negated and you have introduced one more variable, that is y2. So if there is a satisfying assignment of the x for the C set instance, then one of the literal xi must be made true. Assigns yj is equal to 2 if j less than I minus 1 and yj is equal to false for longer j. So whole discussion will be clear with the example here. Suppose you have this kind of assignment is satisfiable but none of the x is true. So here we are restricting that x values are not true. So if x values are not true, that means for first literal this is false, this is false, so we have to force y1 to be true. Similarly, x3 is not true, and as we have assigned here it true, in this clause it will become false. So now x3 and minus y1 are both false, so again we are forcing y2 to true. So on. If you will keep on making all the y's true, you may reach to a satisfiability. But then the last clause is false. So there is a little more to the reduction for handling clause of one or two literals. So replace x by x plus y1 plus y2, x plus y1 minus y2. So here in earlier case it was the x1 plus x2. Now here you made it as x plus y1 plus y2 like this. So replace w plus x by w plus x plus y and w plus x plus minus y. So remember the y's are different variables for each CNF clause. So this reduction is surely polynomial. In fact, it is linear in the length of C set instance. Thus, we have poly time reduced C set to 3 set. Since C set is NP complete, so is 3 set.